So, hi, Assalamualaikum. Today, I and my group members will present exploring the impact of noise on the modulation technique using AI simulate data. So, my name is Raihan Ilyani. My members is Nur Iza Izati and Nur Nusrina. Okay, first I will present about abstract summary. So this study looks at how Gaussian and impulse noise affect analog modulation method like AM, FM, and SSB. Since we didn't use tool like MATLAB, we use generative AI to simulate the effect. The results show that FM is the most resistant to noise, AM is the weakest, and SSB are performed in between, depending on the filter. Okay, next for introduction. Analog modulation methods like AM, FM, and SSB are still widely used in areas like radio, aviation, and low power device. But this signal can be disturbed by noise. Gaussian noise comes from heat integration, while impulse noise comes from sudden strong interference. Knowing how each method handle noise help improve signal quality. Since we didn't have software like MATLAB, we use AI tools to simulate and study the signal. Okay, next is literature review modulation overview. AM uses less bandwidth but its easy affected by noise. FM is a more stable and resistant noise, well, which is why it's common in radio. SSB safe spectrum and work well for long distance communication. In the practice, adaptive system can switch between AM, FM, or SSB on the signal to noise ratio or SNR.
Hi, Assalamualaikum. My name is Nur Izadati. My metric number is B1223105554, and I will present impact of noise. In this study, we analyze how different types of noise affect analog modulation techniques. First, Gaussian noise, which represent continuous background interference like thermal noise, strongly degrade AM signals because it directly affects the amplitude. However, it has a lesser effect on FM since FM encodes information through frequency instead of amplitude. Next, impulse noise, which is caused by sudden high energy spike like switching transient, has a severe impact on AM, often causing signal clipping or distortion. It also moderately affects SSB depending on the filter quality and receiver design. Overall, FM shows the best resistance to both noise types, and when combined with proper filtering techniques, it provides the most stable and reliable performance across noisy environments. Next is AI in communication. Artificial intelligence plays an increasingly important role in modern communication systems. Advanced artificial intelligence (AI) models such as convolutional neural networks CNN and long short-term memory (LSTM) are used to recognize modulation types even when signals are affected by noise. Additionally, generative AI tools can simulate wireless signals and predict how different modulation schemes will perform under various noise conditions. Furthermore, AI-assisted denoising technique helps to enhance FM signals and reduce interference caused by both Gaussian and impulse noise. These AI applications show how machine learning can improve the reliability and efficiency of analog communication systems. Next is methodology and key results. In this study, we use AI tools like ChatGPT to analyze how noise affects AM, FM, and SSB signals since we didn't have access to real simulation software like MATLAB. The AI helped us create a comparison table showing how each modulation type responds to Gaussian and impulse noise. The key results show that AM was the most affected by both types of noise, often becoming unusable. FM performed the best, staying clear and stable even under noisy conditions. SSB was in the middle. It performed better than AM, but not as well as FM. These findings are consistent with existing theory and show that AI can be a reliable tool for studying communication systems when lab-based tools aren't available.
Assalamualaikum, my name is Nonisina binti Saimi. Now I'll be moving on the next part. This table presents a hypothetical analysis of the impact of noise on three different modulation techniques, AM, FM, and SSB. Two types of noise are considered, Gaussian noise and impulse noise, and their effects on signal quality, SNR tolerance, and overall comments are summarized. For AM modulation, Gaussian noise causes high distortion due to amplitude sensitivity with a poor SNR tolerance of less than 50 dB. Impulse noise is even more damaging, leading to server clipping and very poor signal reliability. FM modulation shows much better resilience to noise. Gaussian noise has only a minor effect thanks to frequency modulation. With a good SNR tolerance between 10 and 20 dB, impulse noise causes only slight disturbances and the signal remains recoverable. For SSB modulation, Gaussian noise has a noticeable but manageable impact, assuming proper filter design with a moderate SNR tolerance of around 15 dB. Impulse noise can distort voice clarity, and while SSB has some resilience, it may require additional filtering for optimal performance. Overall, FM shows the highest tolerance to both types of noise, while AM is the most vulnerable, especially to impulse noise. Next, for the discussion part, the study used AI-generated simulations to compare the effects of Gaussian and impulse noise on AM, FM, and SSB modulation. It found that FM performed the best because its frequency-based encoding makes it more resistant to noise, especially Gaussian noise. AM performed that worse as it is highly affected by both noise types due to its reliance on amplitude changes. SSB showed moderate performance and served as a balance between AM and FM, working well in limited bandwidth environments but requiring good filter design. The use of AI made it possible to test these modulation schemes quickly and without hardware, offering useful insights for system design. For example, FM is best for noisy environments, SSB is good when bandwidth is limited, and AM is only suitable for simple or non-critical systems. However, the study also notes that these results are based on simulations and not real hardware tests, so further validation is needed using tools like MATLAB or GNU Radio. To wrap up our presentation, I'll now present the conclusion where we summarize the main findings. This study used AI-generated simulations to compare AM, FM, and SSB modulation under Gaussian and impulse noise. It found that FM performed the best because it handles noise well through frequency-based encoding. AM performed the worst due to its reliance on amplitude, which makes it very sensitive to noise. SSB showed balanced performance, working better than AM but not as good as FM, especially with proper filtering. The findings show that AI tools like ChatGPT can help with early testing and system design, saving time and resources in noisy communication environments.
That's all from us. Thank you.